Yeah. I can't tell you how many lectures I've lost to this thing the last week. Of course, the last two were kind of my fault, but technical difficulties. Anyway, I was saying I'm going to postpone the exam until Wednesday so we can start off this morning by reviewing the homework, addressing any questions you might have. Just make sure everybody's clear and got everything sorted in their mind before the exam on Wednesday. And then we will use the rest of this today to get started on the new material, Chapter 3. So, who's got questions? Who wants to kick this off? 41? Ball player catches a ball 3.4 seconds after throwing it vertically upward. Is that the one? Yep. All right. So the ball player throws the ball from here. It goes straight up, turns around, and comes right back down. This is at 3.4 seconds. This is at t equals 0 seconds. All right, well, looking at our four kinematic equations, which one do you think would be the most appropriate to use? Okay. Okay, but in order to use that one, in order to use V equals V naught plus AT, we would have to know the initial velocity that he threw the ball with. Okay, which equation are you? Show me which equation you're talking about. I have it written down. Okay, that's actually not. Go back to page. Let's find where they have the table that shows all of the four kinematic equations. Because I think you have what you've written down there is a simplified version of one of them. But say again? You're saying V equals V naught plus AT? No. No. And we do not have the velocity, the initial velocity. We don't have that. We can replace I mean x and minus x. So we can get 2. Look on page 29, and you'll see the four kinematic equations in the box there. Page 29. Let's Go ahead and put these back up on the board. Because I think the one that you're pointing out, that you're trying to use, I think it's a simplification of one of these, but in general, it's not the general case. So, the first one that we've been discussing is v equals v naught plus acceleration times time. The second one is x is equal to x naught plus v sub naught times t plus 1/2 at squared. Then we've got v squared is equal to v naught squared plus 2 times the acceleration of x minus x naught. And then finally, the average velocity is equal to the final velocity plus the initial velocity divided by divided by 2. Now, those are the four standard kinematic equations. Now, what information, let's take this one step at a time. What information are we given in this problem? We're given time, total elapsed time. Now we can assume that y sub naught is 0 because we can set 0 at any arbitrary point. We do not know what the maximum height the ball is going to reach. We do not know the initial velocity it's given. We do not know the final velocity that it achieves. We do know that A is equal to G, which is minus 9.8 meters per second squared.
I was thinking of the actually I wouldn't that still cancel out.
No, T here is the final T. Now we can come here and look on page 35 at example 2-12. Everybody there? We know that, what do we know about this point here? We know that at the very top, at the very apex of that trajectory, the velocity is going to be 0. Right? Can we assume that the velocity, that the initial velocity that it has here is going to be the same velocity that it has at the end? Maybe. We probably can. But let's think this through before we jump to that conclusion. Okay, yeah, that's why. I'm sorry. I sent you down a wrong path by bringing up this example because it gives us the initial velocity. That's not going to help us. Yeah. So let's go back and look at our problem. The one equation up here that we do have information we can plug into is this one. And one of these things. So we know that we can write y, and we're just going to reorder the equation so that instead of horizontal, it's written to reflect vertical. We have y is equal to y sub naught plus v sub naught times t minus 1/2 g t squared. Okay? Now, in particular, we know that t is 3.4. We know that y naught we've set to be 0. And so we can write that as y equals v naught times 3.4 seconds minus 9.8 meters per second squared divided by 2 times 3.4 seconds squared. Aha! Are we looking for the time that it takes for the ball to go from here to here? And this is what I think, this is what you were saying a while ago. And you're right. Y final is when the ball is right back where it started from. So in this case, y is equal to y sub naught is equal to 0. That means now we can put 0 is equal to the initial velocity times 3.4 seconds minus, what's 9.8 divided by 2? 4.98, something like that. $4.9. And 3.4 squared is 11.56. And we can do the math, do the arithmetic here. Multiply 11.56 by 4.9, that gives us 56.644. The seconds squared cancel, which leaves us with meters. Now, velocity is in meters per second multiplied by seconds, so this term is meters. Minus meters is equal to 0. We add the 56 to both sides. We divide both sides by 3.4 seconds. And that gives us V sub naught is equal to 16.6 meters per second. Now, does everyone see how we've gotten this so far? Say again? The Y. Well, no, look what we're talking about. We're talking about a ball's trajectory that starts off here at Y0. And where is Y final? Y final is at the same point, at the same height. So Y equals Y naught. We have Y naught is 0. You go up to, this is Y max up here. But the final Y at the end of this trajectory is right back where he caught it at. Remember, the total time we're given of 3.4 seconds is not the time it takes the ball to go from here to here. It's the time that it takes the ball to go from here to here and back to here. I knew I should have taken time to make another cup of coffee before I came and started this. Does everyone see what's going on here? That our final Y and our initial Y are the same Y. We set it at 0. And now this equation describes the entire trajectory. Displacement versus distance, right. At this point, what we're using here is neither. We're using an initial position and a final position. So yes, if we were talking about the displacement of the ball at the end of this trajectory would be 0. Because Y final and Y initial are the same. That means that this Y, the final Y, where the ball ends up, is at the same place as this. That these are both the same value of Y. It starts off at Y equals 0. It ends at Y equals 0. Now, we haven't finished the problem. All we've determined so far is the initial velocity that the ball was thrown with. Okay, this is not our final answer yet. All we've determined so far is when the guy threw the ball, he tossed it up, this is the initial velocity he gave it. And with this initial velocity, it took 3.4 seconds for the ball to go up and come back down. We don't know yet how high the ball went. All we know is that he threw it with 16 2/3 meters per second of initial velocity. Okay? But what's the question asking for? Well, at first it's asking, with what speed did he throw it? This is the first part of your, the first answer that they're asking for. He threw it with this much speed. The second question being asked is, how high did the ball go? What height did it reach? What is Y max? Well, what do we know about Y max? The velocity at Y max is 0. Now, which of these four equations would be most useful to us? Second one still? Yeah, I would think that the third one would be the simpler one to use. We now know that the initial velocity was 16.6 repeating meters per second. We know the velocity when it reaches the top is 0. We know what A is. That's just minus G, minus 9.8 meters per second squared. And we know that the initial position, Y sub 0, is 0. So let's rewrite this. V squared equals V naught squared. Well, no, not plus, because we're doing this. We're turning this over for vertical use. And this becomes minus 2 times 9.8 meters per second squared times Y minus Y naught. Well, Y naught is 0. There's only one variable up here that we don't know we can solve for, is Y, and that's the one we want. Everything else we've got. V squared at the top is 0. 0 squared is still 0. The initial velocity is 16.6 repeating meters per second. Square that minus, what's 2 times 9.8? 19.6 times Y, because Y sub 0, the initial Y is 0, so Y minus 0 is still Y. Subtract this from both sides, and we end up with 19.6 meters per second squared times Y is equal to, what's 16.66 squared? $277.78. Meters squared per second squared. Divide both sides by 19.6. One meter cancels, the per second squared cancel, and we're left with Y equals 14 meters. Is everyone see how we got that? That's the second part of the question. The question asks for what speed did he throw the ball with and how high did it go? Any questions? Let me give you one to think about. Okay, that is not going to end well with me if I hear it very much, so I'm going to close this door. Yeah. And if I start talking real loud, you know what it is I'm trying not to hear. Because nothing will cause me to launch a Technicolor yawn faster than hearing or seeing someone else do it. So we're going to just keep on going and pretend like that didn't happen. I'll give you a question to think about. What if we wanted to know how long it took the ball to reach a height of 10 meters? We know that the peak, the apex here, is 14 meters. If we wanted to find out how long it would take to reach 10 meters, how would we find that? We set up the same initial equation. Y final is 0. We set that equation up, we start solving for y as 10 meters, and we end up with an equation that looks like this. And once we've converted it into this form, where it's ax squared plus bx plus c, then we solve for the quadratic formula. But when we do, what do we get? We get two values, at which point two different times that it takes for the ball to get to 10 meters of height. Why would that be? One's going up, one's coming down. So you get two times. What happens if you end up solving the equation and you get a negative number? What does that mean? If you get a negative number, what that would mean is that you're trying to solve the equation up here, where the ball never reaches. And if that b squared minus 4ac turns out to be 0, so you only get one solution to the quadratic formula, what does that mean? No. What that would mean, but that's close. What it means is you just happened to plug in the exact value of y that got it right there to the very top. It only gets there once and then it comes back down. So the higher you get, the smaller that b squared minus 4ac gets. As that number gets smaller and smaller and smaller, it vanishes to 0 at the apex where you have only one solution, and then it goes negative. Does everyone understand how to interpret what this quadratic formula is telling you now? Is there any other homework questions? 46 and 43? Well, this is exactly what we just talked about, isn't it? All right. Stone is thrown vertically upward. Here, your question, you help read me the numbers. It's thrown vertically with an initial velocity of 24 meters per second. What else is it asking? How fast is it going when it gets to 13 meters? Okay, 13 equals y naught, that's 13 meters, equals y naught plus 24 meters per second times t minus 9.8 meters per second squared divided by 2 times t squared. 9.8 divided by 2 is 4.9, so this is, and we know y naught is 0, so we end up with 24 meters per second times t minus 4.9 meters per second squared times t squared. And that's all equal to 13 meters. Well, first we check our units. If t is in seconds, so seconds cancel seconds, we got meters, minus meters per second squared times second squared cancels, leaving meters. So we've got meters equals meters minus meters. We're good so far. Everybody still with me? We're going to add 13 meters to both sides of this equation, and we're going to rearrange it so that it is in the standard quadratic form. We add 13 or subtract 13 meters from both sides, and we end up with 24 meters per second times t minus 4.9 meters per second squared times t squared minus 13 meters. Well, the only thing we need to do to put it in the standard format is move the squared term up front. And now, A is equal to minus 4.9, B is plus 24, and C is 13. It's all equal to 0, so T, we're not solving for X, we're solving for T. T is equal to minus B, 24, plus or minus the square root of B squared minus 4 times A times C, all divided by 2A. 4 times A times C is minus 4.9 times minus 13, all divided by 2 times minus 4.9. So now we need calculators. (24 squared is 576. Four times A times C is 254.8. You'll notice the two negatives cancel to make it a positive, so it is still a difference. And all of that divided by 2 times minus 4.9 is, what's that? 9.8. Okay. Minus 9.8. So our radical, under the radical, we have 576 minus 254.8. That gives us 321.2. All divided by 9.8. Square root of 321.2 is 17.9 and some 2's. So, if we start with negative 24 and we add 17.92, we end up with minus 608. That's 6.08 divided by minus 9.8. Or, if we subtract minus 41.92 divided by minus 9.8. Now, first thing to notice is that we end up with positive numbers in both cases. When the ball is thrown, it gets to 10 meters the first time in just a little over half a second. And about 3 3/4 seconds later, it comes back down and hits 10 meters again. 10 meters is what we were looking, 13 meters, sorry. Does everyone see how this is done now? Any questions? Say again? How fast is it moving at a height of 13 meters? Okay. How would you find that one? Which one of these equations would you use? Say again? Do we know the initial velocity? We do. All right, walk me through it. Let's use that equation. Walk me through it. What's the first thing I'm going to write down? V squared equals V naught squared, what? Plus 2A, what is A? Right? Okay. How do we rewrite this to put it in the vertical? Say again? I'm sorry. Y instead of X? Say again? Exactly. A is now G. What do I do now? Everybody else can chime in too. By doing what? Taking the square root of both sides? Okay. Plug what in where? Okay. What is that? You mean shoot, you don't know. $19.6 times Y minus Y naught. Okay, now what? Say again? Why is that? Okay, so Y would be 13 meters. Y naught is 0. So now we have the square root of 24 squared minus 19.6 times 13. Say again?
Final answer is 17.9.
17.9?
Yeah.
Okay, but let's get there one step at a time for everybody else. What's 19.6 times 13? $254.8. What's 24 squared? 576. Okay, now what's the difference of those? 576 minus 254.8? Say again. 321.2. And that gives us a final answer of, somebody confirm that the square root of 321.2 is 17.9? Okay. That's how we get the other answer. Of course, that you also need to be sure and specify that that's in meters per second. And we've already discussed why there were two answers to part B. What other questions do we have? Somebody asked about what? Say again? 37. Mary and Sally are in a foot race. When Mary is 22 meters, oh yeah, this one gets complicated. This one's fun. Okay. Mary and Sally are in a foot race. When Mary is 22 meters from the finish line, she has a speed of 4.0 meters per second and is 5 meters behind Sally. So we've got this finish line. We know that Mary is 22 meters from the finish line. And that she has a speed of 4 meters per second. Her velocity is 4.0 meters per second. We also know that 5 meters ahead of her is Sally. And Sally has a speed of 5.0 meters per second. Now, what are they asking for? Sally thinks she has an easy win, and so during the remaining portion of the race, she decelerates at a constant rate of 0.40 meters per second squared. Now, how do we deal with this? That it says she's decelerating. She's accelerating down. She's slowing down. So we make it a negative. It's 0.4, right? 0.4 meters per second squared. And that she decelerates at that constant rate all the way to the finish line. Now, the question is, how fast does Mary need to accelerate for the duration of the race in order to cross the finish line at the same time as Sally? What's the first thing we should figure out? Anybody? Because we're not going to solve this in a single equation. We're going to have to do this in steps. So what's step one? What's the first thing we need to know? Okay, let's back up and try this from the other direction. What is the question asking us? We need to know the acceleration Mary needs in order to finish at the same time as Sally. So, in order to find out what acceleration she needs, what are we going to need to know? We need to know time, certainly. We absolutely need to know how long it's going to take her Which of these equations are we going to be using? Well, let's take a look at this one. This is a nice simple one. There's acceleration, there's her initial velocity. We need to know her time, but then we also need to know her final velocity. Do we have any idea what their final velocity is going to be, what her final velocity is going to be? So that's out. We know her position, we know her final position, we know her initial velocity. If we knew her time, we could solve for her the acceleration that she needed. So this one's a potential one. Again, we don't know her final velocity. We do know her displacement, but we would have to know her final velocity in order to solve for her needed acceleration. And again, we don't know her final velocity, so that doesn't really help us either. That pretty much means we need to use this equation in order to solve for t. But in order to solve for her acceleration, but in order to do so, we have to know how much time it's going to take her, how much time she's going to spend accelerating to that finish line. So, how do we find out how much time she has? How do we solve for the amount of time she has to get to that position? What time are we looking for? The time it takes them to finish? Well, that's the time we're looking for, but we know everything we need to know right here to find out how much longer it's going to take Sally to cross the finish line. And that will tell us how much time Mary has in order to get to the same point, which will then allow us to solve the acceleration that she needs. Okay, well, which one of these? Again, we don't know her initial velocity, so we can't solve for her. We do know her acceleration, and we know her initial velocity, but we don't know her final velocity, so we can't solve for time. So again, we're going to have to use this general equation in here. What is her? We know her, well, let's see. We're saying, how are we going to do this? We'll say this is x equals 0. This is then x equals 5 meters. And this then is x equals, what was it, 22 meters. Okay, so let's write this equation for Sally and find out how long it takes her to get to the finish line. We know that x is 22 meters is equal to 5 meters. I'm going to write this bigger. X equals 22 meters is equal to 5 meters plus, what's our initial velocity? 5.0 meters per second times time plus, or actually plus, what's her acceleration? 0.4 meters per second squared, but we're dividing it by 2, so what's 0.4 divided by 2? 0.2 meters per second squared times squared. It is negative, isn't it? Very good. Now, first thing I would do is subtract 5 from both sides and gives me, what's 22 minus 5? 17 meters is equal to 5.0 meters per second times time minus 0.2 meters per second squared times time squared. Or in the standard form of the quadratic equation, we're solving for t, so t is now equal to what? Minus 5 what's 5 squared? 25 minus 4 times 0.2 is what? Say again? 4 times 0.2? Okay, but it's negative, so it's gonna become, well, let's finish writing this out. 2 times a would be 2 times negative 5, so that would be minus 10, right? What's 0.8 times 17? So we'll just 25 plus 13.6 divided by minus 10. And 25 plus 13.6, 30, what, 38.6? And what is the square root of 38.6? 6.21? Now, what's negative 5 plus 6.21? Negative 5 plus 6.21. Say again? So it becomes plus 1.21 over negative 10, which would give us a negative number. And then what's the other negative 5 minus 6.21? 11.21 divided by negative 10. So 1.21 divided by negative 10 is minus 0.121. The other possibility is plus 1.121. So what would our final answer be? Okay, I want to take a minute and let's look at this. We get two results because we're solving a quadratic equation. What would the negative result in this case mean for us? That if she slows down, she would cross the finish line minus 1.21 seconds before she started slowing down? What does that tell you? Yeah, well, it's a good guess, but don't overthink this. Okay? What this is telling us is that the mathematics is giving us an answer that is not meaningful. Okay, so we ignore that answer. And we get the one answer that is meaningful, that at 1.121 seconds later, all right, that's it. 1.121 seconds later, she crosses the finish line. That means we now know how long Mary has before she needs to cross the finish line. What do we know about Mary? We know her position, we know her final position, we know her initial velocity, we know the time that she's going to take to get there. All we have to solve for now is what acceleration she needs to cross the finish line in the same amount of time. Is it really already over? Yeah. Turn in your homework on Wednesday and be ready for the exam.